Well, I purchased this ADCOM GFA-5300 MOSFET audio amplifier off eBay last week. It's was advertised as right channel having distortion. With my testing, I came to find out it was left channel. They must have had their speakers hooked to the wrong outputs. Some of the initial testing that I did showed that the bias was way high. It's supposed to be set at 20 millivolts, and it was like 83 on one channel and 100 on the other. So I dropped that down to where it needed to be, which is 20 millivolts plus or minus 2, I think. And also the DC offset was way high. It was like 14, 15 millivolts, and it should be at 0. So I thought maybe that was cause of the distortion. So I powered it up and ran it off my little Heathkit audio generator, and sure enough, the left channel definitely had a large amount of distortion. It looked like crossover distortion. That's what makes me wonder whoever was working on this prior may not have known a whole lot of what they were doing, and they were adjusting the bias, trying to get rid of crossover distortion. But what I found was I did some more testing, and I tested the DC bus voltages, and on the left channel, I can't remember if it was a positive or negative rail, whichever, on the left channel, there was like almost 3 volts of AC ripple. So I'm thinking, well, okay, it seems kind of strange, but maybe one of that particular bus capacitor had failed. Well, it turns out it was a lousy solder joint. I literally, once I unbolted that board, that particular capacitor, I just popped right off. There was basically nothing holding it on at all. So you see that crappy glue on there, which had nothing to do with that. But tested the capacitors out. They're 10,000 microfarad, 63 volt. They don't seem to be leaky, so that's good. But they're all the way down to, one was as low as 7,900 microfarad, and the best one was like 8,010 microfarad. So I've ordered some new ones. But in the meantime, I thought about it, and I decided I'm going to solder these back in and put this thing through its paces just to see if there's any other problems. I'm sure the 8,000 microfarads is probably enough if you're not really hammering on it, that it's not going to make any difference. But I want to put it under a load and see if any other problems crop up. So I'm going to take this thing out in the garage and blow some of this dirt out of the inside of it first, and then solder those capacitors back in and scrape some of that lousy glue off of there, and see what happens. I'll be back. Well, I just came back from the garage after blowing this thing off. Looks a little bit nicer now. Definitely had a cloud of dust in my face. Now look at the soldering on this. You want to talk about absolutely just lousy soldering. And actually this one here is the one you can see. The other ones I desoldered. You can see this one here, the solder just literally broke. I'll definitely solder them on better. They didn't even clean the flux off of this thing or anything. So, of course, I don't know, maybe somebody was working on this, it's hard to tell. Like I said, I'm going to test this for a little bit more for functionality now, and then I've got parts on order that probably won't be here for a week or so. And then I'm going to pull each one of these amplifier boards out and replace some caps on it and go through and probably resolder some of the solder joints there too. But I'm going to put this thing together now, and I'll hook everything up and we'll see what the scope shows, see if the output looks better on the left hand side. Well, I've got this thing back together. Had it idling here for about 8 or 10 minutes, and you can see the bias is pretty doggone close to 20 millivolts like it should be. These pots in here, adjustment pots, are incredibly touchy. I think I'm going to, once I tear this apart and start replacing these caps and a few of the others, I think I'm going to replace those with some 10-turn or 20-turn pots that I have around here. They're all four of them for the bias and the offset are 5K. I'm certain I have some 5K around here. But anyways, I've got this thing all hooked up to the auto generator, and I got my little GFA-5300 tablet type oscilloscope here. So let's see what happens. I'll try to hold this. Oh, and also I gotta run this off the cord because my battery's no good. But my little light there kind of went pop right before I started this video, and now it's dark over here, so it's a little bit darker than what it was. But let's run this voltage up. I'm on 0 to 1 volts RMS. This particular amplifier requires a preamp, so that's a good voltage to run to it. So we'll see what happens here. So there's the full 1 volt, looking a lot better now. Putting out 28 volts RMS on the left, 27.3 on the right, and still no distortion. The top might be just starting to come off of that one a little bit. So I'll run this back down and I'll go to 3 volts so I can drive this a little bit harder, and we'll see what happens here. We'll get it to right until where it starts to flatten off. Oh, right about there. Back it off just a hair. So about 32.2 and 33.2 RMS. So the right channel is about a volt lower. But that's, I'll have to do the math on that, but that's actually pretty good. I think that's more than the 80 amps that this, or I mean 80 watts that this amp's supposed to put out. I'll have to do the math on this real quick, and I'll be back and I'll give you the results. Well, according to the calculations here, looks like the left channel is putting out 135.3 watts and the right channel 128 watts. That's considerably above the 80 watts that's advertised. Now, I'm feeding in a sine wave, and I don't have any distortion meters or anything like that. I'm just looking at it at clipping, so I'm sure that's probably it factors into things. But regardless, it's definitely putting out more than what it's advertised at. After I do a little bit of work on this, we'll see if that improves any, and I'll have a video at some point later on and we'll look into that. Well, it's now about a month later, well, about 3 weeks later. I started on this project day or so after Thanksgiving, and now it's a week before Christmas. Took a while to get some of the parts in, and then I just haven't had time. But you can see I've got the new bulk capacitors installed, and also after doing some testing, I decided to replace every single capacitor in this unit. Probably about 70% of them were bad, whether high ESR or capacitance out of spec or whatever. So I went through and I replaced every single capacitor in this amplifier. Made no sense to me to replace the 70% that were bad and then have to come back in here 6 months later and replace the rest of them. Just do it all at once. Also put the 10-turn potentiometers in for the bias and the DC offset. Spent some time last night. I hooked it up first to my dim bulb tester and preset the bias so it didn't go way through the roof, and then plugged it in just directly to my isolation transformer that's over here, and reset the bias again. And now we're directly hooked to the power line, plugged it right into the power line. So I'm going to do the final adjusting now. And one other things I didn't mention, sort of things that kind of like extend projects. When I went to take that nut off so that I could get the circuit board out for, I can't remember, left or right channel, the one pin broke right off. So I had some nice output terminals that I could put in its place, but they were larger diameter, so I had to crimp some larger ring terminals on. I didn't have any that were appropriate for that, so I had to wait for those to come in. That's just the way projects go sometimes. But I'm going to plug this in. It's already plugged in. I guess I'm going to push the power cord, or push the power button, and let's see where our bias is at now and our DC offset. I already know that it's quite a bit different than what it was on the isolation transformer, but let's plug it in or push the button and see what happens. See, we're over 20. I was at 20.5 last night, and that was after probably about an hour of run time. It held steady at 20.5. We're a little bit above that, and our DC offset has gone up considerably now that we're off of the isolation transformer. So I'm going to have to adjust that as well. So what I'm going to do now is I'm going to leave this thing powered up for 10 minutes, or until it seems like everything is stabilized, and we shall see where we're at. See, that's already stabilized down a little bit, and once everything stabilizes here, I'll be back. Okay, I'm back after about 15 or 20 minutes. As you can see, everything came right into adjustment. We're at 20 millivolts, and also the DC offset is reasonably good. It seems like the one channel floats around an awful lot, but it's not going above 10 millivolts, so we're going to try it out. Next step here is I'm going to connect my audio generator up to it and see what we get. Now, the eagle-eyed among you may have noticed early on in this video, 3 weeks ago would have been for me, that the oscilloscope was only showing 100 Hertz whenever I did the initial test with this. I seem to be having some trouble with the multiplier on my audio generator, so I have to bump it up. I think I bumped it up to 1010 Hertz, or 1.1 kilohertz, I mean, and I'll test it at that. That might be why this thing showed way more power output than it was rated at, because it was only actually being fed 100 Hertz. So we'll see what happens now with the new capacitors and all the solder joints resoldered and the whole works, and see what it does. Okay, so I've got my audio generator connected up, and let's see what we get here. Run this thing up. So it just clips. So we've got 30.6 RMS on channel 2 and 30.2 RMS on channel 1. So 1 is the left channel and 2 is the right channel. So we're pretty even. Notice I have the frequency of 1.01 kilohertz. If I turn it to 1 kilohertz, it goes to 100. I got to do some work on that audio generator, like I said. But next step now, I guess, I'm going to put the cover on this thing, and I have to do a little bit more pre-work on the preamp, which should be finished very shortly. And we're going to connect this up, and I'm going to put some YouTube royalty-free music on, and we'll crank this thing up and see how it sounds. Okay, so I've got these two installed here in my little stack in the basement, and got them both on, and I've got some royalty-free music from YouTube here. I'm going to start one off here and we'll see what we've got. Well, one thing that I see definitely has plenty of volume, very little bass. I'll have to play around with the preamp to see if I can get any more bass. Maybe I'll have to put an equalizer on it or something, but it's still it is functional and no distortion. Actually, zero distortion, which is good, but definitely a little bit lacking in the bass end. So I think this will probably be it for this project here. They're both functional. They just need a little bit of tweaking from here, I guess, and it may sound pretty good. Maybe different types of music, or maybe more with voice, it'll sound good. But definitely, like I said, it kind of harsh sounding and basically no bass, very little bass. So, you know, at least they're functional.